Just moments ago, NASA's Perseverance rover transmitted the first ever close image of the mysterious interstellar object 3I/ATLAS. And what scientists found has already sent shockwaves through the global astronomy community. A new image of 3I Atlas has revealed something truly strange. Scientists have discovered that sunlight behaves in a completely different way around this object than anything we've ever seen or even imagined before. Look at this image. It was captured by the Mastcom Z camera on NASA's Perseverance rover on Mars. It shows a faint blurry spot in the Martian sky, the location where scientists expected the interstellar object 3I Atlas to appear. This is the first time ever we've seen 3I Atlas from such a close distance. However, the original transmission wasn't smooth. Data logs show a 47-second gap during the image download, something rarely seen in Mars communications. NASA engineers later admitted that one image file arrived corrupted and had to be manually reconstructed. This unusual interruption has raised questions among mission specialists about what might have caused such a significant data disruption. In the image, the comet appears only as a faint smudge next to a group of stars, each about as dim as magnitude 8. When the image reached mission control, one planetary scientist reportedly said, "That's not a comet. That's something else." Internal discussions about its unusual appearance have since been kept private, though sources close to the investigation suggest that the object's visual characteristics don't match any known comet profile in NASA's extensive database. Another piece of data also shows something moving in the Martian sky, which scientists believe is the interstellar visitor 3I Atlas itself. Interestingly, this picture wasn't taken exactly during its closest approach to Mars. The Perseverance rover captured it one day before that moment. Scientists say that the actual closest approach could only be properly observed by Mars orbiters. However, due to NASA's current shutdown issues, it may take some time before they release those detailed close-up images of the object. During 3I Atlas's near pass by Mars, the Perseverance rover also recorded increased Martian surface activity. The image shows dust devils swirling around the rover and a large dust storm forming on the horizon. Perseverance's environmental sensors also detected short-lived magnetic spikes during the same window, as if an external electromagnetic field briefly swept across the Martian surface. These magnetic anomalies lasted approximately 12 minutes and registered at levels 3 times higher than typical Martian background readings. The tail of this interstellar isn't visible in the rover's images. It was too faint at that time. Scientists have already discussed how this comet appears unusual because of its lack of a visible tail, something very rare compared to most comets. However, as it approached Mars, the comet began to develop a thin tail, though still much fainter and narrower than any seen before. Some experts now suspect the faint tail we see might not be made of gas at all, but of charged particles, something only seen when a body interacts directly with solar radiation in an artificial way. This hypothesis, while controversial, is gaining traction among researchers who specialize in plasma physics and electromagnetic phenomena in space. If confirmed, it would represent an entirely new category of celestial behavior. There are also other images of 3I Atlas that show more details of its shape, but these have not yet been fully verified. Based on those unconfirmed visuals, the comet seems to be elongated in shape, making it look more like the first interstellar object Oumuamua and less like 2I Boris. A leaked image analysis from the European Southern Observatory suggested an unexpected geometric alignment along the object's edge, a pattern too regular to be explained by natural formation. NASA declined to comment. Independent astronomers who reviewed the leaked data described the edge pattern as suspiciously linear, with one researcher noting that the probability of such regularity occurring naturally is statistically improbable. Recently, the interstellar comet 3II Atlas passed fairly close to Mars on October 3rd, coming within about 0.19 astronomical units. That's roughly 28 million kilometers away. It's now racing through space at nearly 200,000 miles per hour, heading toward its closest point to the Sun, known as the perihelion. However, things just took an unexpected turn. Astronomers believe that 3I Atlas may have been affected by a coronal mass ejection, a massive burst of solar energy and particles from the Sun. But after the CME, several observatories detected a brief, narrowband radio spike lasting only 0.3 seconds from the same coordinates as 3I/Atlas. Scientists haven't confirmed what caused it, though the signal's frequency and duration don't match any known natural solar or interplanetary phenomenon. After this solar event, the comet suddenly disappeared from view, likely due to both its increasing distance and the Sun's glare. Also, Earth is now moving in the opposite direction relative to the comet, which makes it even harder to see against the bright background of stars. As a result, 3I Atlas won't become visible again until later this year. And just when many thought it was a normal comet, recent new observations revealed unexpected anomalies in the comet structure and light behavior, features that challenge what we currently understand about such objects. Astronomers have recently conducted the first polarimetric observations of the interstellar comet 3I Atlas. When sunlight travels through space and hits an object like a comet, the light doesn't just bounce straight back, it scatters in many directions. Each tiny dust grain or ice particle around the comet acts like a little mirror, changing how the light behaves. When this light hits something, for example, the dust around a comet, those ripples can become more organized. Instead of moving randomly, the waves start to line up in certain directions. This lining up of light waves is called polarization, measuring how much the light becomes polarized and in which direction. Astronomers can tell a lot about the dust it bounced off, its size, its shape, whether it's rough or smooth, and whether it's made of ice, rock, or a mixture of both. When scientists observe comets, they often find positive polarization when the comet is seen at larger phase angles. At small phase angles, many comets show negative polarization. When astronomers observed the interstellar comet 3I Atlas, they found that its negative polarization was extremely strong, much stronger than in any comet we've seen before. This discovery left even experienced astronomers puzzled. One team member called it optically impossible because the polarization data implied the surface was absorbing light like a metallic material rather than reflecting it. The implications of this finding are profound. If the object is indeed absorbing light in this manner, it suggests a surface composition unlike anything found on natural comets in our solar system. This was a big surprise. It means that the dust grains around 3I Atlas are very different from those in comets that come from our solar system. They might be rougher, more irregular, or made of materials that are rare or unknown here. This is the first time we've observed such behavior in an interstellar object. While we've studied several comets from our solar system and interstellar visitors, none have exhibited the unique polarimetric characteristics seen in 3 Atlas. Its extreme negative polarization, with a minimum of -2.77% at a phase angle of 6.4 degrees, is unprecedented among known comets. This strange behavior hints that 3I Atlas could have formed in a completely different kind of environment, possibly in another star system, or at the very edge of our own solar system, where conditions are much colder and icier. Scientists have previously claimed This object is older than our solar system itself. According to their research, it likely came from the inner regions of our galaxy, making it one of the most ancient and mysterious visitors ever observed passing through our solar neighborhood. In another surprising observation, scientists have detected an unusual chemical composition around this object. They found that the environment surrounding this interstellar visitor is quite similar to the atmosphere and surface conditions of our neighboring planet Mars. This strongly suggests that the object did not come from a typical comet-forming region like those in our solar system. Instead, it might have originated from a planetary surface, possibly from a world with conditions similar to Mars. Some claim the object seems to glow in strange ways, not seen in regular comets. That might mean that as it approaches the sun, it could evaporate a lot more, or even break into pieces when it nears perihelion. Well, scientists have also observed some other mysterious behavior in this object. We've already noticed that 3I Atlas is losing mass as it's surrounded by a visible cloud of gas. Normally, when comets shed gas, the release of material pushes them slightly off course, like a rocket firing tiny thrusters. But 3I Atlas is behaving very differently. Even with these gas clouds forming around it, its path doesn't seem to be affected at all. Some scientists think this unusual behavior might actually explain its enormous mass, as the way it holds itself together while forming a gas cloud could mean it's much denser and heavier than expected. Early estimates suggested that 3 Atlas is at least 1,000 times more massive than any comet we've seen before. Recent studies now estimate its mass could be over 33 billion tons, an almost unimaginable amount for a natural comet. Recently, Professor Avi Loeb divided all the unusual observations about 3I Atlas into two main categories. In the first category, he listed the anomalies that might be explained with more data in the future. These include things like its size, the strange anti-tail, a forward jet of scattered sunlight that's about 10 times longer than it is wide and points toward the sun, its unusual chemical composition, and its strong negative polarization of light. These first category anomalies are puzzling, but potentially solvable. As we gather more observational data, develop better models, and refine our understanding of interstellar chemistry and physics, we might eventually find natural explanations for these features. However, even within this category, the combination of so many unusual characteristics in a single object remains statistically improbable. In the second category, he placed the anomalies that may remain puzzling forever. These include the fact that the trajectory of 3I Atlas is aligned with the ecliptic plane, the same flat plane where all the planets orbit the sun within just 5 degrees. This alignment is particularly striking because interstellar objects should arrive from random directions in 3-dimensional space. The odds of naturally aligning so closely with our solar system's orbital plane are extremely small. Another strange detail is that the arrival time of this interstellar object seems to have been perfectly timed to pass close to Mars, Venus, and Jupiter. The orbital mechanics required for a random interstellar object to achieve close approaches to multiple planets in succession suggests either extraordinary coincidence or something more deliberate. Even more mysteriously, the direction from which the object arrived is aligned within 9 degrees of the famous WOW signal detected on August 15, 1977, which some scientists once thought might have been a message from an extraterrestrial source. Even more mysterious is that its inbound path aligns within just 9 degrees of the 1977 WOW signal, a famous unexplained radio burst some once speculated came from intelligent origin. The odds of such alignment happening by chance are estimated at less than 1 in 10 million. This statistical improbability has reignited debates about the WOW signal itself and whether there might be a connection between these two enigmatic phenomena separated by nearly 5 decades. The WOW signal, detected by the Big Ear radio telescope at Ohio State University, remains one of the most intriguing unsolved mysteries in the search for extraterrestrial intelligence. It was a strong narrowband radio signal that lasted for 72 seconds and has never been detected again, despite numerous attempts to relocate it. The fact that 3I/ATLAS appears to be arriving from the same general direction has caused some researchers to reconsider whether these events might be related. Professor Loeb has argued that those who strongly insist 3 Atlas is just an ordinary naturally formed comet should be held accountable to explain all these unusual coincidences through purely natural processes. The burden of proof, he suggests, should fall equally on both sides of the debate. Those claiming a natural origin must provide compelling explanations for the statistical improbabilities, while those suggesting alternative hypotheses must present testable predictions. The scientific community finds itself in an unusual position. On one hand, the principle of Occam's razor suggests we should prefer the simplest explanation, which would be that 3I/ATLAS is a natural comet with unusual but ultimately explainable properties. On the other hand, the accumulation of anomalies, each individually unlikely and collectively extraordinary, challenges this default assumption. What makes this case particularly interesting is that many of the anomalies Professor Loeb places in his second category are not matters that will be resolved by better instruments or more data. They are statistical and geometric facts about the object's trajectory, timing, and origin direction. These are fixed properties that won't change with further observation. The debate highlights a fundamental tension in modern astronomy. How many unlikely coincidences must accumulate before we seriously consider alternative hypotheses? At what point does the natural explanation become more extraordinary than the artificial one? These are not easy questions to answer, and reasonable scientists can disagree. As we continue to observe and analyze 3I/ATLAS during its perihelion approach, an eventual departure from our solar system, new data will undoubtedly emerge. Some anomalies may find natural explanation, others may deepen the mystery. The object represents a unique opportunity to study something truly from beyond our solar system, regardless of its ultimate nature. The case of 3I/ATLAS also raises important questions about how we approach the study of interstellar objects in general. With the discovery of Oumuamua in 2017 and now 3I/ATLAS, we're beginning to realize that interstellar visitors may be more common than previously thought. Improved detection capabilities mean we'll likely discover more such objects in the coming years and decades. Each discovery provides an opportunity to learn about conditions in other star systems, the composition of interstellar space, and the variety of objects that traverse our galaxy. Whether these objects are natural or artificial, they carry information about places and processes we cannot yet reach with our spacecraft. The strong negative polarization observed in 3I/ATLAS suggests unusual surface properties that could inform our understanding of how different star systems form planetary and cometary bodies. The Mars-like chemical composition hints at processes of planetary formation or erosion that might be common in certain stellar environments. Even the trajectory anomalies, if they prove to have natural explanations, could teach us about gravitational interactions in dense stellar regions, or the effects of radiation pressure on unusually shaped objects. Science advances, not just by confirming what we expect, but by investigating what surprises us. As 3I/ATLAS approaches perihelion, astronomers around the world will be watching closely. Will it survive the intense heat and radiation of close solar approach? Will it fragment, as many comets do, or will it pass through unscathed, maintaining its structural integrity in a way that adds yet another anomaly to the list? Ground-based telescopes, space observatories, and planetary missions will all play a role in continued monitoring. The James Webb Space Telescope, with its extraordinary sensitivity in the infrared spectrum, could potentially detect thermal emissions from the object that reveals details about its composition and internal structure. Radio telescopes will continue scanning for any unusual signals or emissions. While the brief radio spike detected after the coronal mass ejection has not repeated, astronomers remain vigilant for any further electromagnetic anomalies. The scientific papers analyzing the polarization data, chemical composition, and trajectory will undergo rigorous peer review. This process, while sometimes slow, ensures that claims are properly scrutinized and that alternative explanations are thoroughly considered before conclusions are drawn. That's all for today, but before we go, there's one more thing you need to know. Update. Just as we finished editing this video, the European Solar Orbiter detected a faint infrared echo from the same direction as 3I/ATLAS, suggesting the object may have survived its closest approach to the Sun. We'll keep watching. The story of 3I/ATLAS is far from over, as this mysterious visitor continues its journey through our solar system. Each new observation has the potential to either resolve the anomalies or deepen the mystery. Whatever the truth turns out to be, this object has already earned its place as one of the most intriguing interstellar visitors ever detected.